So we left off, we finished talking about the structure of arteries, the structure and function of arteries, and now we are going to be looking at the structure and function of veins and capillaries for this part. Okay, so as you can see here, there are three kinds of veins: large veins, medium-sized veins, and venules. So there are three different kinds. Okay, so the capillaries form venules, and then venules form veins, and then medium-sized veins form large veins. Veins have all of the tunics that we were talking about before, all the three tunics. But there's a little bit of a difference, because when you are looking at a vein, all of the tunics are generally thin. Oh, where's my mouse? Are generally thinner. Oh, here we go. All of the tunics are generally thinner compared to that of arteries. So when you are comparing a vein with an artery, veins, the walls of veins are usually thinner overall. The other difference between an artery and a vein is that veins don't really have a lot of recoil, and they also don't have a lot of smooth muscle, okay? So veins essentially are there to bring the blood back to the heart instead of distributing the oxygenated blood. Another thing to think about with veins, the veins are designed, particularly the large veins and the medium veins, and also the venules, they're designed to kind of hold a lot of blood, but the pressure is actually quite low, whereas the arteries deal with blood coming, through them at higher pressure. And the other difference between an artery and a vein is that veins, medium-sized veins, actually have these valves, and we're going to look at those later. Here's another picture of an artery versus a vein. You don't need to memorize everything in this picture. All you need to do is just make sure you answer the learning objectives that are at the front of this slide set, and just have a look at the major differences between the two and how that is related to their job. So let's look at the vein. It's very thin, like thinner. It's kind of low pressure. Artery is thicker, more high pressure. Okay, so arteries, there are three kinds of arteries, and they all have all of the three tunics. Remember these guys? The veins, there are three kinds of veins, and they all have the three tunics. But now what we're going to do is we're going to look at capillaries, and capillaries only have one tunic, so they don't have all three, only one. Okay, so let's have a look, before we get into the capillaries themselves, let's have a look and see how blood flow is controlled. Now, we did see this before a little bit. Remember how we said that the arteriole can control how much blood goes through the capillary bed? So that's one way, but another way is, can you see these? So you have your capillary bed, so you've got your artery end and your venous end, and you've got like your tissue here, which is like a town. and each cell is like a house. And the capillaries are like the streets. Can you see how like there's a main road going from one side of town to the other side of town? Yeah. So the capillary is they're like the side streets of the town. So the capillary bed also has smooth muscle bands. Can you see here? So when these smooth muscle bands are constricted, then it's going to stop blood from going through the side streets. They're like traffic lights. So when these smooth muscle bands shut off, they shut off the side streets and the traffic can only go through this main road. When these smooth muscle bands are relaxed, then traffic can go all through these side streets and all through the entire capillary bed and not just through the main road. Okay? So remember again, blood flow is governed by tissue demand. So if the cells that live here aren't doing a lot of activity, they don't need any blood. They don't demand the blood. If cells here are undergoing lots of activity, then blood will be delivered to them. Okay, so what we're going to do now is we're going to look at the 3 different kinds of capillaries. But before that, let's look at how red blood cells go through the capillary. Let's get my pointer back. Oh, why doesn't that work? I don't know why that doesn't work. Just get rid of that. There we go. I want to show you this little video of how red blood cells pass through the capillary, because the capillary is the business end of anatomy and physiology. It's the interaction between the blood and the cells. Here we go. I'm just going to show you this. Here we go. Look at that. They go through really, really fast. Look, all of these red blood cells going through really, really fast in the capillary. Can you see them? Oh, look at them all. They're rushing by. Or look at the individual ones. You can see all the individual ones. Wow, look at that. So the capillary is very important because that's where all the action happens. Okay, so let's have a look at the 3 different kinds of capillaries, and each kind of capillary has a different job to do. So this is the first type of capillary, and capillaries differ with regards to their permeability. So this one is the least permeable, which means that we can't really get a lot of things through it. Now, don't worry about this parasite business. All you need to understand is that you've got a basement membrane, then you've got endothelial cells. So this is endothelial tissue. So capillaries are only made up of one type of tissue, which is endothelial tissue, and that makes up the tunica intima. They don't have all the other layers, the other 2 outermost layers. Can you see how these guys are really close together? So if you want to get anything from the blood to the tissue, we have to go through the endothelial cells. Okay, so some of them have little gaps, some of them don't. So the point here is to have this capillary really, really tight so it controls what is moving from the blood into the tissue. It's very, very tightly controlled. Look at this one. Don't worry about the parasites. This one has a basement membrane and endothelial cells. But look at this. The endothelial cells, not only do they have gaps between them, but they also have holes in them, which means that it's now easier for blood, fluid, or things that are in the blood to move from the blood and into the tissue. Because we can go via this gap, through this pore, or we can go through the actual endothelial cells. So that's used in certain spots. So in some places in the body we use this kind, in other places in the body we use that kind. And then in some places in the body we use this kind of capillary. Look at this basement membrane. It's patchy. Look at the big holes in the endothelial cells and look at the huge gaps. Wow. So in this capillary, what the role of it is that it allows lots of things to move from the blood into the tissue and vice versa. Okay, so can you see how we went from very, very tight, really hard to get things in and out, to medium, to everything can come out and then everything can come back in, except a red blood cell, of course, because it's a little bit, yeah. But this is just a different type. Okay. Oh, one more thing. So let's talk about histamine. Histamine is a molecule that is released by cells called mast cells. Now, histamine acts on the capillary. Let me just show you what it does. When histamine binds to a capillary, it does two things. The first thing it does is that it makes the diameter of that capillary bigger. So it's vasodilation. And because you are making that diameter bigger, what happens is that there are more gaps now between the endothelial cells, which means that it increases capillary permeability. Okay, so that's two things that you need to remember about histamine, and you're going to see that later on when we do inflammation. Histamine causes vasodilation and causes increased capillary permeability because those endothelial cells are now pushed further apart and now there are more gaps. See here, no gaps? Gaps. Okay, yay.